All right, so finding the third side of this triangle, the 5 root 2 has to be the C, the hypotenuse. So 5 squared plus b squared equals 5 root 2 squared. So 5 squared is definitely 25 plus b squared. 5 root 2 squared. So 5 squared is 25. Root 2 squared is 2. So 25 times 2, which is 50. So 25 plus b squared equals 50, b squared equals 5, or 25, and b is 5. So both legs of this triangle are 5. So I'm going to evaluate the 6 trig functions. We'll run through these. Pause the video if you want to, or if you've already done it, just going over your answers. Opposite over hypotenuse is 5 over 5 root 2. I am going to rationalize the denominator. I'm just going to come back to that. Cosine of theta is equal to adjacent over hypotenuse, which is also 5 over 5 root 2, which I will rationalize. I'm just going to come back to it. The tangent of theta is opposite over adjacent, which is 5 over 5, which is simple enough to find simplify that to be 1. Okay, the cosecant is hypotenuse over opposite or the reciprocal of sine. So 5 root 2 over 5. And these 5's do cancel out, so the cosecant is root 2. The secant is the reciprocal of the cosine or hypotenuse over adjacent. 5 root 2 over 5. Again, those cancel, just root 2. And then the cotangent is the reciprocal of tangent. The reciprocal of 1 is 1, or adjacent over opposite is still 5 over 5, so it's still 1. Okay, so the sine and the cosine. Now we have to clean these up in a few different ways. As long as I clean it all up, I'll be fine. The only thing that I need to multiply by is the root 2. So it's not wrong to multiply by 5 root 2. I don't need to. All I need to do is get rid of the root. So the numerator is 5 root 2. Off to the side here, I'm going to do the denominator is 5 root 2 times root 2. So root 2 times root 2 is just 2. So 5 times 2 is 10. So 5 root 2 over 10, because both this 5 and this 10 are outside of the square root, 5 over 10 reduces to be 1/2. So the sine is root 2 over 2. And then the cosine is the same exactly as the sine, so all that work later, root 2 over 2. So I've simplified those 6 trig functions. The practice problem in the right triangle, theta is an acute angle, and cosine of theta is 7 over 10. Evaluate the other 5. So I like having a picture in front of me. It's definitely not drawn to scale, but I'm going to put theta right here. So now I have to be careful with what they give me. They give me the cosine, which means that they give me adjacent and hypotenuse. They give me that the adjacent is 7 and the hypotenuse is 10. So if I do 7 squared plus b squared equals 100, b squared equals 51, and 4 doesn't go into 51, 9 doesn't go into 51, so root 51. So I've got the cosine that I already know. So I'm going to start with the sine of theta is opposite over hypotenuse, root 51 over 10. The cosine of theta is adjacent of, we already know it. So technically I don't have to write that. It's not wrong to write it, but I'm not going to waste the room because I know I'm going to probably run out of room anyways. So the tangent of theta is opposite over adjacent, which is root 51 over 7. The cosecant is the reciprocal of sine, or hypotenuse over opposite, which is 10 over root 51, which I am going to simplify. I'm just going to come back to it. The secant is the reciprocal of cosine, or hypotenuse over adjacent, which is 10 over 7. And then the cotangent is the reciprocal of the tangent, or adjacent over opposite, which is 7 over root 51. So I guess I could do that one first or come back to it. So whenever I've got these roots involved, the two that I have to rationalize the denominator might be different, but there's typically going to be two. So in cosecant, I need to rationalize the denominator by multiplying by root 51 over root 51. So I get 10 root 51 over 51. So you might be able to see some patterns and just tell me what the cotangent's going to be. It's not wrong to show this step, 7 root 51 over 51. So the sine, the tangent, the cosecant is already in that final answer in the box, the secant, and the cotangent.